In this session, we'll be looking at the proof of differentiation from the first principle. And we know that differentiation is just the process of obtaining the general gradient of a curve at a point. In finding the gradient of a linear function, we use, which means that we need 2 points to find the gradient of a linear function. But differentiation is telling us that it is possible to find the gradient of a curve at 1 point only. So let's take it that you have the curve, so of the function this. So let's take it that this is my function f at x, and this is the curve of this very function. Now we have point A and then point B on the curve. Let's try to find the coordinate of point A and then the coordinate for point B. Now we know that the coordinate for point A is going to be in the form of x and then y. So the coordinate for x, tracing it to the x-axis, so from this very junction is going to be our x. So it means that we have x. Now the corresponding y coordinate is going to be in the form of f of x, and we know that f at x is equal to y. So we are going to have the y coordinate to be f at x. Now let's write the coordinate for b. Now let's take it that the distance from x to the point B on the x-axis, let's call it h. So it means that from x to this very junction is going to be the coordinate for x. So to find the coordinate for x is going to be what? X plus h. So we have x plus h. Now its corresponding y coordinate is going to be f at x plus h. Now let's find the gradient for these very 2 points, and we know that the gradient given 2 points is given as change in y over change in x, which is y2 minus y1 all over x2 minus x1. So from here, this is our x1, this is our y1, this is our s2, and this is our y2. So let's substitute it back. We have y2, which is f at x plus h, minus y1, which is what? F at x all over x2. So we have x2, x plus h, minus x1. x1 is x. Now let's simplify small and then see what we are coming out with. So we have the function f at x plus h minus f at x. We can see that positive x and this will go away. So we'll be left with what? H. We don't want to find the gradient at 2 points. We want to find the gradient at 1 point only. Let's say point A. Now we can do that by moving point B closer and closer and closer to point A. Now as we move point B closer and closer to point A, let's observe what happens to the length of H. So let's take it that we are moving point B. Now point B is here. What happens to the length of H? We can see that the length of H will reduce. Now let's take it that point B is moved from here to here. What happens to the length of H? You can see that the length of H has reduced from here to this very part. Now assuming point B is here, so the length of H is reducing. Now we can move B closer and closer until it gets nearer and nearer, or it laps on point A. Now if that happens, what happens to the length of H? we can observe that the length of h reduces and becomes smaller and smaller and smaller until it approaches what? 0. Now, as the length of h approaches 0, then we can take the limit of this very function. So we are going to get the limit as h approaches 0 of f at x plus h minus f at x all over h, and then this become the first derivative with respect to x. This is what we refer to as differentiation from the first principle.